Alright guys, so let's do a quick little refresher on sum and difference and double angle. Basically, just going to go and write the formulas out for you real quick. It goes sine of x plus minus y is equal to sine x cos y plus or minus sine y cos x. For cos double angle, goes cosine of x plus or minus y. Looks kind of like cos x cos y. And for cosine, it goes in reverse order. So it'll actually go minus plus sine x sine y. For double angle, it's pretty straightforward. Sine 2x becomes 2 sine x cos x. And then for cosine double angle, there were 3 versions where the initial version was cos squared x minus sine squared x, and from using our Pythagorean identities, we could make this 1 minus 2 sine squared x, or 2 cos squared x minus 1. So these are the formulas you're going to want to keep in mind, again, for this week's quiz. Let's just go and review what a double angle problem looks like. Well, a double angle problem, since that's dominantly going to be in your worksheet, double angle kind of looks like this. If I have given, say, tangent is equal, tangent of theta is equal to, let's say, 4/3. And then I'm being told that theta is in between, say, 180 and 270. If I was going to ask you to find, then, say, sine 2 theta and cos 2 theta, using this information, how would we do that? Well, the first thing to note is that this piece of information here is telling me that we are in quadrant 3. Okay? Why is that important? Well, it's because if I look at the triangle in quadrant 3, that means that the 4/3, which is going to be the opposite over the adjacent sides, they're both going to be negative. Right? And so that's going to have ramifications for my answer. So if I'm going to find sine of 2 theta, well, that's going to be 2 sine theta cos theta. Well, how could I possibly know what these two values are? Well, given the fact that I have this triangle here, I have to do a couple of things. One, I'm going to find that hypotenuse. So I can use Pythagorean theorem, or I can know that it's a 3, 4, 5 right triangle and know the hypotenuse right away. Based on that, I know that within the context of this problem, sine of theta is equal to, looks like, negative 4/5. And that cosine of theta is going to be negative 3/5. So again, I go back to the question, how does all of this help me in this problem? Well, hopefully it's relatively straightforward. I'm going to go 2 and then times whatever sine of theta was in that particular problem. What was sine of theta? We just found it. It was negative 4/5. And then the cos theta will follow in suit. So I just have to punch those things in. And what's that going to give us? Well, that's going to give us definitively 25 on the bottom. It's going to be definitively positive because we have negative times negative, so 12 times 2, so 24 over 25. And there's your sine double angle right there. Cosine double angle works in a similar way, so let's go ahead and do it. Cos 2 theta is equal to cos squared theta minus sine squared theta. And so what I have is a thing squared minus a thing squared. So what was cos again? It was negative 3/5. And then sine was negative 4/5. Again, remember that mistake we talked about in class. You do not let those negatives cancel each other out. This negative will most definitely go away, but not because you're subtracting it. It's really because you are squaring it. Which means, ultimately, your answers will be subtracted, meaning your double angle value is, in this case, negative. So how does this work in the context of one of our problems here? Well, if we look at number 19, kind of goes like this. 19, by the way, is a 6-part problem. There are 6 subsections to 19, so it's a little longer than you think. I'm not going to waste your time by going over all of them. I'll probably just go over some of the ones that I think will capture all of the information here. So, if I'm given this information, cosine of alpha is equal to rad 5 over 5, and all this stuff, and then sine of beta is equal to all this stuff, how do I proceed to attack this problem? Well, first thing I'm going to do is when I see this expression here, this cosine alpha being rad 5 over 5, I'm just going to go ahead, and you don't have to do this, but I like to unrationalize the denominator, and it just helps me move a little bit faster. I know that, did not explain that. The reason why I proceeded to draw the triangle in the way I did is because I know that alpha is between 0 and pi over 2, meaning that my triangle for alpha is in the first quadrant. Okay. This is my angle alpha right here. And cosine is the ratio of adjacent over hypotenuse. So I'm going to go ahead and draw that out. And then to find this third side here, like we always do, I'm just going to go ahead and use Pythagorean theorem in reverse. So 5 minus 1 is rad 4, so that's going to give me a 2. So hopefully that makes sense. From here, I can go and find an additional piece of information. I'll go and mark that in red. If I know this triangle to be those dimensions, I can also tell that sine of alpha is going to be 2 over rad 5. Now again, why is this helpful? It's because cosine of alpha and sine of alpha are inevitably going to be showing up somewhere in the context of these 6 answers, right? So I'm setting up the problem right now. I have not even started yet. Sine of beta is equal to negative 4/5. We know that beta is in between negative pi over 2 and 0. Well, what does that tell us? Well, that tells us we're in quadrant 4. So this is a quadrant 4 triangle, and I'll go and label this while I'm at it. I forgot to tell you. Quadrant 1. Hopefully that makes a little bit of sense. Let's go ahead and draw a cool quadrant 4 triangle here on this side, where this is my angle beta. From here, it's negative 4/5, so that's going to be opposite over hypotenuse. And I know that this side is going to be negative because we're in the 4th quadrant. And based on our Pythagorean triples, I know this thing is going to be 3. Hopefully we're doing okay so far. Also, remember, they gave to us that sine of beta was negative 4/5, which means from here I can find cosine of beta to be 3/5. And again, why is that important? It's important because sine of beta and cosine of beta are inevitably going to be showing up in the context of somewhere between A and F. So, let's pick one. Why don't we let's pick B to knock out first. I'll do B. So if I wanted to evaluate cosine of alpha plus beta, what I'm going to look at is I'm going to look at expanding this out exactly as I know it. I know it's cosine alpha cosine beta minus sine alpha sine beta. Well, again, what does that even do? How does that even help? Well, I think I know what cosine alpha is. I'm going to go back to this dude. See this guy here? He's 1 over rad 5. And then cosine of beta, well, that's this dude over here, so he's 3 over 5. Minus, what's sine of alpha? Well, sine of alpha was over here. That's 2 over rad 5. And then sine of beta was this dude over here, so that's negative 4/5. So what I get is I get 3 over 5 rad 5. Check it out. Minus a negative, it's going to be plus 8 over 5 rad 5. So what I get is 11 over 5 rad 5. And that's as far as I need to go for that problem. So again, you see how I extrapolated the information from both triangles simultaneously. Hopefully that makes a little bit of sense. Alright, let's change gears here, change to green. Let's take a look at sine 2 alpha. Well, what does sine 2 alpha ask me to do? Well, just like in the previous examples, I'm just going to expand it the way I normally do. That's going to be 2 sine alpha cos alpha. Well, the 2 carries along, it comes along for the ride, but what was sine alpha the entire time? Well, sine alpha is going to be this 2 over rad 5. And then cos alpha, well, that was already given to us. That's 1 over rad 5. So I'm thinking that if I just multiplied it across, I'd get 4/5. Cos 2 beta would work in the same way. Let's do cos 2 beta, which is question F. Cos 2 beta would be cosine squared beta minus sine squared beta. And I would use all of my beta information from my beta triangle, which is this triangle on the right side right here. So I've got a thing squared minus another thing squared. So the first thing squared is going to be the cos, so that's going to be negative 4/5. And then the next thing squared is going to be 3/5. So I feel like we've seen this example enough times to know what's happening here. So I'm just going to go ahead and scroll down here. 16 over 25 minus 9 over 25, so I get positive 7 over 25. And that's how you do the worksheet. Alright, see you guys tomorrow.